Hi, in this tutorial we're solving exercise 2.3 from a textbook. In this chapter we are getting specifications for databases and we will work in their design using the ER model. Then our main job will consist of identifying entity sets and relationships. So let's see. So this is, I'm going to use this as the pointer. I'm going to go into the first bullet of the specification and talks about professors and some of their attributes, social security, name, age, and so on. So then professors is an entity set. Then for that we need to draw a rectangle, and then we will have their attributes listed in ellipses. So for that I have this here. So we'll identify the first step, which is this. So the first step, we draw that rectangle, then we list the attributes there. That's it. Okay, then we go on the next projects. So projects have a number, a sponsor, starting and ending date, and a budget. So then this is another entity set and it's been described by its attributes. And now look at that, what we have here in parentheses, NSF, we're not going to be able to capture that into the ER because this is a domain for a specific attribute, which is a sponsor name. However, we could define that in Oracle as an integrity constraint, and we will see that later. So we could take note that in SFA, for example, possible domain value is not being included into the ER. So then again, we draw another rectangle with the attributes, which will be this. Oops. This will be my second step. I will draw a rectangle for projects, and then I will have all those attributes listed there. Okay. Then we continue with the next bullet, and then that's graduate students, and then again they is listing me some attributes. Then this will help me to identify that, and then in parentheses I have some possible domain values like MS, PhD. Then again, those can be defined as integrity constraints later, but they are not described into the ER. So for that, we draw another rectangle, which will be this. So this is my next thing that represents the information that I'm getting from that bullet. Okay, then now, next I got this. A project is managed by one professor. So now here, look at the difference. We're talking about a project that has been already identified as an entity set. And it's talking about a professor, which is also another entity. So we're talking about two possible entities. So this is a relationship. Usually in entities are nouns and relationships are verbs. So here it seems that the relationship between projects and professor is the professor managed the project. Then and then it's identifying the role here of the professor as the PI or the principal investigator. So this is a relationship which is managed. You can see if I have that here. So between professors and projects, we have the relationship managed there. And it says that is one professor. So then here, that's what we had that one over here. One professor manage one or more projects. Okay, so now each project is worked on by one or more professors. So that's what we have to work on. So then here, this is another relationship. So something is the manager, so the professor one is the manager or the principal investigator, and the other is that there are other professors that can also work in the project. Okay, so Professors can manage and or work on multiple projects, and that finalize the idea of the many-to-many here and the one-to-many over here. So we have several professors that can work on several projects, and those projects can have several professors and so on. Now, each project is worked on by one or more grad students known as the project research assistant. Okay, so sorry, projects here. So there is a project, and then we got grad students, and what else do they say? One or more, so that's how many can work on projects. Okay, so now the next bullet is the one that is going to be a little confusing because now it says about that when a grad student, so it's talking about that, okay, what we was discussed before when we are working, but then it said when that happens, there has to be a professor that supervises the work, and grad students can work on multiple projects. Okay, so in this case, we're talking about professors and talking about the uh, supervising the project, but when the students are working on it. So let's see, then the best way will be then to make this a ternary relationship. Let's see if I can do that right. You see, it was binary, but I think it looks better ternary because then here we're going to have the information of the professor, the information of the project, the information of the grad student, and that happens when the students are actually working on that. Now, for this, then we don't need anymore the see. What I want to do is that, do you see that I had an N and an M there? I don't need that anymore. Internally, I mean, I can leave it there, that's fine. I guess I can leave it there. But it's not needed. Internally relationship, we don't specify many to many, one to many. Why we don't specify that? Because when we apply the rules of the transformation, that doesn't make any difference. So I guess I just leave it. I was trying to do the text box there to delete that information, but I think it's just fine. Okay, so the next piece of information that we have is about departments. Then departments have a department number, department name, and main office. So this is now a new entity set, which I have it right here. And I'm specifying what they just told me. And then the next specifications is a department have a professor known as the chairman who runs the department. So professor is an entity, department is an entity, then there is a relationship. The relationship is runs over the chairman. So I have that here. And then it says have a professor, which is one who runs the department. And then sorry, I was having some difficulties here. So let me see here. So now let's go to the next. Professors work in one or more departments, and for each department they work in, there is a percentage. Okay, so then we got that here, professors. So we got some professors, and because they can work in several departments, look at that works in has a percentage time. Okay, now grad students have one major department in which they are working on their degree. So grad students is an entity and department is an entity, so this has to be a relationship, which is this. So departments, so had several students or students that belong to just one department. That's what they say here. And then each grad student has another. This is another good specification. So a student, it has a relationship with a student. So a student can be the how do they call it, advisor of another student. Okay, so then that will be adding this information, advisor. So advisor one student advises other students. So it's a relationship with itself. So this is a generic relationship. Okay, and that concludes the diagram. I just want to show the solution that the textbook shows for this. And let's see the difference. So in the textbook, they did not, there are some difference on what I have in my solution. And then mainly what you see is that they have this big block. Instead of converting, remember that I converted the relationship between project and graduate students that was binary, I convert that into ternary. They are doing this, they are putting that in a block, and then they're adding another relationship to this, like this were an entity set. We're not doing that. However, I mean, I just want you to be aware of the notation and the possibility. I mean, I don't like that solution. And other than that, that looks the same. Remember that also in the textbook, when they bold that line, means total participation, they have to participate. And then when we have that errors, means one. In my notation, remember when I had that double line, means total participation, that means you have to participate. The single line, that means optional, that means you can have a zero. The n and the n means many, the ones means one, and the ternary, we don't need to specify that. Okay, thank you.